Hi, Dr. Pinzone here from Hyperthermia Cancer Institute to talk today about metabolism and how it relates to cancer. So, when we think about metabolism, broadly defined, it's any chemical process within a cell, but the way we can think about it is those processes that support the maintenance of the cell that you're talking about, and then there are those processes that allow that cell to then divide, and usually it's a stem cell we're talking about in that situation. So in cancer, you have dysregulation of both metabolic processes. That is, metabolic processes designed to support the cell, as well as those designed to proliferate the cell. And so the main therapies, including chemotherapy, radiation therapy, immunotherapy, are designed to get at that proliferative process. What hyperthermia does is it actually targets the maintenance process so that it allows those other agents to work better. How does it do that? Very straightforward. So we use ultrasound to heat tumors to about 106 to 109 degrees Fahrenheit. That seems to be a really important window that is maybe just a little bit more than you might get with a fever, and we do it in a local area, right over the tumor that we're treating. So what does that do? It actually opens up blood vessels. Those blood vessels are typically poorly formed in tumors that are solid because there's a lot of pressure, and so the center of the tumor has low oxygen. And the cells, because there's so much mutation going on in cancer and tumors, learn how to live in a low oxygen environment. Well, when we apply heat and we then open up blood vessels, three important things happen. One, you get a lot more delivery of systemic agents. Mostly we're talking about chemotherapy, but these days targeted agents and immunotherapies get delivered to the center of the tumor more effectively as well. Second, the radiation works much better in a high oxygen environment because it uses oxygen to damage the DNA, which signals those cells to not be able to divide anymore. And third, when we heat, it is analogous to giving that portion of the body, including the tumor that we're aiming at, a fever. And what happens in a fever? You get secretion of heat shock proteins. Heat shock proteins are responsible for allowing the immune system to recognize foreign entities, foreign proteins. And in this case, these are the mutated proteins that are inside of the cancer cells. So as those proteins are released by hyperthermia, but more so by chemotherapy or radiation, and then you're heating the environment, causing the secretion of certain heat shock proteins, those heat shock proteins allow dendritic cells, a certain part of the immune system, to take those proteins, process them, present them to T cells, and those T cells then come in and act against the cancer cells to destroy the cancer cells. So you've got those three mechanisms of action, all by using gentle heat to alter the metabolism of those cancer cells.